Hello, and welcome to our very first unit, very first chapter, very first section of our geometry class. I want you to organize your notebooks very well. So we're going to start off with the very first page being a table of contents. You're going to see that with the number 1 in the top right corner. We're going to number every page as we go along. If you want to pause the video and write this down, you absolutely could. But also make sure that the second page is also a table of contents, because most likely it will carry over to that second page, which means our third page is where our first actual set of notes will begin, okay? So hopefully you either rewind the video or pause the video so we could just jump straight into it and you're not just watching me write. All right, so points, lines, and planes is the genesis of geometry, okay? We can't create geometry unless we actually start building something, and that first thing that we have to build from is a point. So let's define it. Now, every time we come up with a definition, I would highly recommend putting this definition on a note card and probably do a drawing that goes along with it on the back side, or definition on the front, or term on the front, definition on the back with the drawing. So a point is a dot, or a point is location, a dot is a location in space. There is no size to it, there is no width, there is no depth. It is just a location in space, okay? And when we're talking about this, for instance, I'm going to do a couple drawings on the far right. So we could, if you want to, you could separate this page by like diagrams on the far right. You absolutely could do that. That's perfectly fine. Move this slightly over. And for instance, I'll put an example here. I'm going to put a dot here that says A. Capital A is for points. We use capital letters. And B. I'm going to put another point here, capital B. Lowercase letters we do not use for points. And we could actually notate this. Notation is for how we write it. We notate it by saying point A. You could also say points A, or point A and B. So point A, point B, or point PT dot A, or PT capital A. So that is a point. A line is the next thing that we could build, because once you actually have 2 points that are not the same point, you connect them and you make a line. So when we make a line, a line is made up of infinite points that continue in 2 directions. So, for instance, if we use this AB example, I'm actually going to use C and D this time. So here I'm going to put a point C, then another point here, D. We could actually connect these 2 points. I'm going to use a different color to actually connect them. Okay. So we have this red line that actually has infinitely many points on here. So if I put another point here, let's call this E. I could put a point outside of C and D. I could put that F. Those are all on the same line. Okay. So we actually have a specific notation for lines. Oh, we could actually even use lowercase letters, I should say. So for instance, I'm going to use the cursive L to note that this is line L. Okay, but you could actually notate this a lot of different ways. For instance, you could call this line CD, and then you could also call this, for instance, line ED, because they all exist on the same line. You could even go further and omit the word line, but you have to use arrows. So I'm going to draw a line directly above it, but I'm going to make sure you put arrows on both sides of the line. CD, you could even call this ED, because they're all on the same line. okay? And last but not least, I already mentioned this, so you could call this line L. So I'm going to actually write this here, line L, and erase the one I originally had, because you could use lowercase letters that are kind of denoted at the very end of an arrow to mark a line. So capital letters for points, 2 points make the line, that's why it's CD, or same thing here. But if it's one letter, it's a lowercase letter, and it's marked at the very arrow of it, typically closer to the arrow, then it is also can be called that line L. So lines are done, points, lines. And then we actually have the word collinear. Collinear should hopefully be a little obvious because it has the word line in it. Co means, like, if you think of like co-captains, you both are captains. So collinear means a set of points that lie on the same line. So I'm actually going to use the line right above this line here to show, for instance, C, E, and D, and even F, are collinear. I'm going to actually put another point here. I'm going to put here, let's call this G. I'm going to say G is non-collinear, meaning it is not on the same line. Non-collinear with CD. Okay? And you can clearly see they are not on the same line. In order for something to be non-collinear, though, this point has to be different than a different line. Okay, for instance, C and G could be collinear because you can make a line from them, but it has to be non-collinear because this is not on that particular line. Okay, so collinear, done. So when we build points lines, we obviously go to planes. Planes is kind of tricky. Okay, it's kind of hard to understand. Typically, we think of a plane like a sheet of paper. Okay, so plane is a flat surface made of at least 3 non-collinear, notice I'm using very specific words, non-collinear points. And it extends in all directions. And extends in all directions. Okay, so a plane will be like a sheet of paper, as I mentioned. Okay, let's make this a little bit bigger. So a sheet of paper, kind of on an angle, and it's okay. Now, a sheet of paper can have infinitely many points. I'm going to use J, I'm going to use K, I'm going to use L, capital L. And then in the top right corner, I'm going to put, or top, let's say bottom right, bottom left, I'm going to put N here, okay? You could actually call this plane, so points have one letter, point A, point B, point C. Lines have 2 letters unless it's a lowercase letter, line L, or CD is a line. Now planes require at least 3 points, 3 non-collinear points, which means it needs 3 letters to name it. So we could actually call this plane JKL. You could actually call it any assortment of the letters. You could call it KJL, LKJ, LJK, it doesn't quite matter. But you could also call this plane N because it has a lowercase letter on the actual plane, and it works out that way as well. Okay? And then our next definition is coplanar. Coplanar. which is a set of points that lie on the same plane. So using the example above, we have JKL are coplanar. JKL are coplanar. But the moment I put a point that is not on that plane, so for instance, I'm going to put a point randomly at the very, very bottom of that sheet that is not on the same plane. I'm going to call this M. M is non-coplanar. Probably should put this in black. It is non-coplanar. So just meaning it is not on the same plane. Okay. Now, that's a lot. Okay, points, lines, and planes are now built up. We can actually start using and building geometry. Okay. And it gets a little tricky, and I'm going to actually jump to the next page just for organization's sake. It goes into we go into intersections. Okay. Intersections occur, so we have 3 different types of intersections, and kind of actually 4, but it's kind of like 3 types of intersections, I should say. We have a lot of different types. We have a lot of different versions of intersections, but intersections of lines and planes. So this is my page 4. Lines and planes. Now, first type of intersection. So I'm going to put 1. We have lines that intersect each other. Line that intersects a line. Making sure that these are non-parallel lines. Okay? When 2 lines intersect, like in a street, if we just draw 2 lines, let's call this AB, and then draw another line, another street that is intersecting with the street AB, let's call this CD. They make an intersection at this particular point, and we could call that E. And we could physically see that a line intersecting with another line creates another point. They intersect at a point. Okay, so that's lines intersecting with lines. What else? What other combination can we have of this? Well, we have lines intersecting with itself. We could also do lines and planes. So the second version of this is when we have a line intersecting a plane. And we have 2 versions of this. Okay, so I'm going to put A and B. When a line intersects a plane, and this one's going to be parallel, that means we have a plane, which is a sheet of paper, and then a line that is parallel to it, which means, so I'm going to call this N again, lowercase n, and then I'm going to call this one, for instance, F and G. So F and G are parallel with this plane. So if FG is parallel to the plane, to plane N, then where's the intersection? Well, since you drew this line on the plane, on the piece of paper, and we know lines go on infinitely in many directions, and there are infinite amount of points on this particular plane, a particular line, that means that this intersects everywhere. There are infinite intersections, okay? So the intersection occurs, everywhere on the line. So everywhere on FG, there is an intersection with the plane or the piece of paper. The other version of this is if it's non-parallel. So for instance, if the line is not parallel or doesn't go in the same direction as the plane, non-parallel, that should be one word. non-parallel. So that means we're going to have a plane still. But what happens when you actually change the direction of the line? Or imagine, for instance, if you have a pen and you decide to stab the piece of paper right through it, and it shoots out the bottom, and that's what the dotted line is for. And then once you could actually see this part again, it becomes solid again. The dotted line is the part you cannot see. The line is shooting through the piece of paper like a pen would stab a paper. Well, the line intersects the paper, or the plane, at exactly 1 point. So if you call this, for instance, M this time, and you call this, for instance, P, they intersect at exactly 1 point. At 1 point. Okay? All right. And in this particular point, this is point, they intersect at point P. So I just recap P. Sorry. All right. Last type of intersection. So this is kind of like 2 in 1. Okay? If it's parallel, then it's everywhere on that line. If it's non-parallel, then it shoots through it like a piece of paper and a pen. The last one is what happens when you actually intersect a plane with itself. And this is the hardest to kind of envision. So I'm going to do my best to explain it. So the third version is when a plane intersects a plane. And this is kind of fun to draw, but it's also hard to draw. Intersects a plane. What happens when two pieces of paper actually intersect and cut each other? So we are going to have a piece of paper that is vertical, just slightly on a slant, so it kind of gives it some depth. And then we're going to have one that is horizontal, or left to right. So I'm going to have a piece of paper like this, and it's going to go to the back, and then it's going to go back here. And then remember, we have dots where we can't see. And then we have the intersection of this where they actually meet. So it's kind of like cardboard, right? When you get cardboards that intersect with each other, they actually make that red line. Okay, so let's call this plane R, the vertical one, or let's call this V. V for vertical, H for horizontal. And we could say here, the planes that intersect form a line. Okay, and we could actually call this line L if we really, really wanted to. Let's put an L there for lowercase l, because it is a line. So in this particular case, plane V intersects plane H, sorry, at line L. Okay, so that is it. We have points, lines, and planes. Definitely get to know these definitions really well, be able to draw them, be able to write them, and notate them. We have collinear, non-collinear, plane, coplanar, non-coplanar, a lot of terms. And then we have their types of intersections, okay? I know it's a lot, but get on top of these definitions, know them through and through, and I promise you it will pay off. If you do have any questions, please let me know, and I will happily answer them. But in the meantime, I'll see you in the next one. Bye.